Consider the experience we have of the world we walk on in our daily lives. The horizon stretches like a straight line, whether along the seashore or across a vast plain. Roads are straight, buildings are upright. All our intuition, all our experiences tell us that we live on flat ground. For thousands of years, humanity has lived by this intuition, imagining the world as a flat plate, a disc on the back of a giant turtle, or a landmass floating on oceans. So how did we overcome this most basic intuition and realize that we actually live on a massive, round sphere spinning at over 1,000 kilometers per hour? And more importantly, what was the irresistible force that shaped our planet into this shape? The journey to this realization is one of the greatest triumphs of human ingenuity. Even when our ancestors imagined the world as flat, they couldn't help but wonder what lay at the edges of this flatness. An ocean teeming with monsters, or an endless void? However, around 2,500 years ago, some thinkers in ancient Greece began to doubt this flat Earth idea. Mathematicians like Pythagoras believed the universe to be in mathematical harmony, and argued that a sphere was the most perfect geometric shape, suggesting that the Earth must also be spherical. But the real evidence came from Aristotle, a keen observer. Aristotle made three simple yet ingenious observations. First, he watched a ship leaving port disappear over the horizon. The ship didn't shrink and vanish as a whole. First, its hull, then its masts gradually sunk below the horizon. This could only be explained by the ship moving on a curved surface. Second, he observed the shadow cast by the Earth on the Moon during lunar eclipses. The edge of the shadow was always, and in every eclipse, part of a perfect arc. The shadow of a flat disk would be circular only from certain angles. At other angles, it would be elliptical or linear. But there was only one shape that always cast a circular shadow, a sphere. Third, he noticed that travelers to Egypt could see stars in the sky invisible from Greece. If the Earth were flat, everyone should see the same stars. This was again evidence of a curved surface. These observations forever changed humanity's view of our planet. So who was this universal sculptor who shaped our planet into its current shape? The answer lies in gravity, the most fundamental and unforgiving law of the universe. Our hero is every speck of dust, every piece of rock that makes up our planet. Our planet began to form approximately 4.5 billion years ago from the aggregation of these particles within a protoplanetary disk. As its mass increased through the accretion process, the force of gravity grew exponentially. Don't think of gravity as merely a downward force. It is a force that pulls everything toward a common center of mass. When our planet grew large enough, its gravity became much stronger than the structural resistance of the rocks. Even if it were initially angular and irregular in shape, gravity would relentlessly pull these corners and protrusions toward the center. Even a massive mountain like Mount Everest can only reach a certain height. If it were any higher, it would crush under its own weight and sink back into the Earth's crust. Gravity forces everything on a planetary scale to form into the most compact, most efficient shape possible. Imagine a giant invisible hand squeezing a large ball of Play-Doh with equal force from all directions. What would the natural shape of the dough be under this uniform pressure? A sphere. A sphere is the most efficient shape for a mass to hold itself together because every point on its surface is as close as possible to the center of mass. The universe is lazy and prefers solutions that require the least amount of energy. The lowest potential energy state for a planet is a spherical shape. But the story doesn't end there, because Earth isn't a perfect sphere. It is a flattened spheroid, slightly flattened at its poles and bulged at its equator. This imperfection is due to Earth's rotation. A point at the equator spins at about 1,670 kilometers per hour. This rapid rotation creates centrifugal force. Just as you're thrown outward on a swing, matter at the equator is also pushed outward. This repulsion works slightly against gravity, causing the equator to bulge. At the poles, because the rotation speed is nearly zero, there's no such effect, and they remain slightly flattened. The difference isn't enormous. The equatorial diameter is only 43 kilometers longer than the interpole diameter. This is such a small difference compared to Earth's total size that when viewed from space, our planet still appears to be a perfect sphere. This slightly flattened shape has consequences. Gravity is slightly weaker at the equator than at the poles, both because of the greater distance from the center and because of the centrifugal force. This shape affects many things, from satellite orbits to ocean currents. In conclusion, the world we live on appears flat, but it isn't. From space, it appears perfectly spherical, but it isn't. The truth, as always, is more subtle and intriguing. The roundness of our planet is no accident. It's an inevitable consequence of gravity, the universe's most fundamental law. It's the universe's favorite shape given to it by mass. And we live on this giant, rapidly spinning, slightly flattened ball held together by gravity. And this imperfect shape makes it the perfect home for us.
The Door to Knowledge, presented by Toyer TV. Don't forget to take your place on this path of discovery and enlightenment.